Right. Hello. Good morning or afternoon or whatever. Um, I have a few minutes to continue the procedural stuff. In case you didn't see the previous one, we have this piece of code in our code base, which is very much object oriented. And I've been exploring like how would we express this with a different paradigm. And it is inherently like stateful, because you have like a WebSocket connection and like, well, stateful, and it isn't pure. Like it doesn't. For me, functional programming, like real functional programming, but like obeying to the rules of composition and all of that stuff, that doesn't make any sense to me in application development. Probably like on doing it on the server, stuff like that, like with more pure data massaging, and not like dealing with, well, arguably this is exactly what that is, what we're doing here. Yeah, that's interesting. Like, how would you even deal with a WebSocket connection in functional programming? I don't know. Like, it's so foreign and exotic to me that I have a hard time even exploring it. While procedural programming, the way it's been introduced to me, it makes a lot more sense to me, because it's basically just not write classes, but write functions, and you keep data separate from the behavior. And you think about the behavior first. That's maybe the most important point. It's like the mental shift is that you think behavior first. So when we implemented this object oriented, we thought about, okay, we want this thing, we want this client that people can consume, and they can interact with like Git and terminals and all this stuff on our process in the development environment. And then we started like constructing concepts around that. But what we're actually doing is that we're just creating a connection to this process in the development environment, and we're sending messages and receiving messages. That's all we do. And with that point of view, you start implementing it in a very different way. So here we're just creating that connection. That's all we do. And then we have functions for figuring out when that connection closes, when it opens, if it's already connected. Yeah, I should probably call this like is open, is closed, so we don't change the terms. And what we did now is that we wanted to actually we want to abstract it. So even though we have an on message, which we still need because this is more for debugging purposes, that's not the functions we're actually going to use at the consumption level, because we care about we really just care about the actual messages, which are notifications, but they can also be responses on requests. So again, we have like a send function here, but I think actually we're going to remove that, because we don't ever want to just send something. We want to request something. And that request is actually part of our protocol. So I think we're just going to remove that, because we're going to implement that as part of a request function instead. But let's do this on notification. So we have something called the picture message handler. And the way it checks, so we get a payload. Oh, the code message, where is that coming from? Okay, so let's just, here we're getting the message. So we're going to copy this stuff, and we are going to put this in here. By the way, I think I'm going to create a presentation for the team on this. Procedural. So we're going to put this stuff in here. Let's see. Where's all this stuff? Let's copy that into procedural. There we go. So we're not actually. Let's just discard the changes on that one. Oh, interesting. Yeah, we have an issue with discarding. I'm not sure why. Why can't you? Oh, now I can't even. Oh my god. Our oldest, she is such an emotional wreck these days. It's hard being like, it's really interesting. I've been talking to my partner a lot about this. It's just insane that at such a young age, like 5, and starting school and everything, we consider them the same age if they're born the same year. So if you're born in January or you're born in like even September, you're considered the same age, which is insane. Like if you put that into like later years, it would be the same as stating that a 20-year-old understands the world and knows him or herself as good as a 40-year-old. It's insane. There's such an insane distance between your development, born in January and in September. And like society has completely missed this. This is part of like the whole what's it called? Industrialization? Is that a word? Anyways, where they just shove people in on this conveyor belt, and we're not taking care of our kids. Like school shouldn't. It's so perfectly okay that school is like per year, but from a certain age, like it should be. For me, it's like, okay, starting school at the age of 6, like the year you turn 6 doesn't make sense. It should be by half year. So if you're born in September and you turn 6 in September, you shouldn't start school that year. You should start school the next year. Because you're closer in development to children who are born early the next year than children who are born the same year as you. Anyways, I really, I thought a lot, reflecting a lot on this, because it's, I think it's really bad. Let's see, send. Okay, we already had a low level send here, but I don't think we actually need that, because here we have the WebSocket connection. Oh, sorry. Connection send. And why the hell wasn't I able to reset the discard? Yeah, I think it's because it's been staged. We aren't able to discard staged files. How do I unstage? Is it like this? Yeah, can I discard it now? Oh, it's interesting. Like it's just, oh, but it did do it. Yeah, we have a bug there. It's annoying. Anyways, let's do what we were supposed to do. The code message is actually coming from somewhere else. We have response. Is response coming from? Where the hell did it get the call message from picture client. Is it actually from picture client? I think it's from picture protocol. This should be from picture protocol. Yeah. And then we have a response, picture response, and we have picture request. Okay, cool. So I think we have what we need here now. Yeah, and picture notification, we already have that. Okay, cool. So let's do picture notification, picture response. Let's shove this into the thing here where it's actually supposed to be dealt with. So we're getting the data here. And on message, aren't we parsing? I thought we were parsing. Oh, sorry. And then this is actually the wrong. It's supposed to be uint8 array. That's what we're actually giving. We don't need that message thing. Is notification payload. And there's no listeners because we'll just call the thing directly. And this is where things are going to get quite interesting, I think. Let's see. What are we? Why is this one? Any? Didn't I grab it? No. Oh, it's not from picture client. God damn it. It's from picture protocol. And why the hell doesn't it? Oh, there's something fishy going on here. With the intelligence. Anyways, we'll figure it out. Do I need a method? Because we're just checking. Yeah, no, we don't need a method here. The cone is notification payload. And shouldn't this be typed now? Yeah. Oh, sorry. Of course. We are... Where are we just giving the params? Why are we only giving the params? Because this is... We should give the whole thing. Yeah, this is weird. What is this? Picture notification payload. Well, this is a picture notification. What's the difference? Type of property method. Type string is not... Oh, yeah. Wait a minute. Wait a minute. How did this actually work? So on notification, where is this? Damn it. Picture client, picture message handler. Oh yeah, sorry. So we have listeners on the method and then we trigger the payload. But we really want, okay, so let's have the method here. And what if we just do CB? What it expects here is a method, and then the params is the payload params. Yeah, so it's basically just typing the... Yeah, but then it's... Because we really want this to be an actual picture notification, but yeah, I think we can just... So the thing is the picture notification payload. Notification payload, where's that coming from? It basically is a picture notification, Um, yeah, right, because we don't know what it is. Yeah, I think we just do something very simple here. So if it is a notification payload, we just say payload as picture notification, because it really is. Okay. So the reason we have onMessage as its own function is, for once, we're going to use it multiple times. It's also used low level for debugging. What we can argue here is that the code message should also be part of onMessage. But I believe when we debug, yeah. Yeah, so the code message should definitely be part of onMessage, because we will have multiple listeners. So here we will have, so for example, when we do a request and we get a message and we also have a notification listener, both of them will actually deal with the message. Like the notification, if it's a response, the notification listener will just ignore it because it's not a notification payload, but it will actually check it. So you don't want to decode the message multiple times. You just want to do that once. So when we do onMessage, we can also argue that we should decode it. So we can basically just say decode message here, and decode message here. Cool. And then this will actually be a picture notification payload, or it will be a response. Do we have response? Picture response payload. That's the only thing you can receive. Why is this? Oh. Yeah, it doesn't seem to auto import anymore for some reason. That's so weird. No, that was picture yeah, notification payload, picture response payload. Yeah, but then you can argue, like, even though these payloads are generic, yeah, I think we did something wrong here. Is notification, we shouldn't check is notification payload, we should just check is notification, and that makes a picture notification. Yeah, and it can also be picture error payload. Yeah. So we're not going to like fix anything here, but we are definitely going to do this. So is notification payload, yeah, it takes any, but at least this is the different payloads we expect. And this should really be is notification payload should return. Yeah, it should really have returned this specific type. Yeah, I'm not sure why we did this. Anyways, so that's notification. And then, yeah, so what's interesting now is that you might have multiple listeners to a notification. That could happen. Like previously, we had like one point where we check if it's a notification payload, and then we call any registered listeners. But now for every listener, we check every payload received if it's a notification payload. So it will do this check quite often when it doesn't need to, and it might do it multiple times as you have multiple on notification listeners. But this is also what I understand is what you pay doing procedural. Like you can optimize the hell out of it with the object oriented. Like it's arguably it's more performant. Like I guess it depends on the scenario, but it's more performant to do object oriented because you can, like it's, yeah, as I said, like in an object oriented manner, you contain behavior and data, so you can also, I don't know how to express that. But the previous code, we just have one point where we receive a message, and then we will kind of map it out to whatever we needed it to be. But also, there was a lot of mapping. It's not very explicit. Like, what happened? Like, if you as a developer wonder what happens, how do we receive notifications? You would have to like dive into Pitcher Client as a class. Then, oh, we have this WebSocket thing, and we have a WebSocket client. We have a Pitcher connection, and then we have this message handler that actually does the parsing of the message. And oh, we have our own listeners. Like it's, while here it's like, okay, what happens when we receive a notification? Oh, when we receive a message, we check if it's a notification, and we call the callback. That's it. And what we can do here, which is interesting, I haven't thought about this. Oh, yeah, because I thought that was a drawback. Yeah, because I thought about it. I thought it was a drawback that we couldn't clear out all the listeners when the connection closed, when it was like disposed, but we can. Like if you see here, if we return a disposer, and what we do is we dispose listener. So we do connection add event listener. Well, we can say on close connection dispose listener. So we do this. This is interesting. This is starting to look functional. Like what the hell is actually going on there? So what we do is when we listen to a notification, we just give a callback, and then we listen to messages if there are notification payloads. But if we close the connection, we dispose of this listener. So there won't be any more calls to this callback, right? So in that sense, you're not centralizing this disposal. You are like distributing it out to where it happens. So we can do the same for on error. What we would do here is, let's see. Let's see, we have the connection, so we would do the same, return on close connection. That's where we actually dispose of the wait, how would this work? So you might you dispose of it if we close the connection, or you can dispose of it manually. So we shouldn't return. Wait, now my mind is bent. So on close, yeah, wait, it shouldn't work like this. We have to we should do this, but we should also yeah, this is what we should do. So it doesn't matter. This makes more sense as well. It's like yeah. Let's see. Let's figure this out. The best way to express this: dispose close and dispose on close. So dispose on message, dispose on close. So the point here is yeah, sorry. Yes. So what we're saying here is that when you listen to a notification, you listen to messages. If it's a notification payload, you call the callback. And then you should be able to dispose of this. Like, you don't want to listen to the notification anymore. So we return a disposer, which calls this disposal. But we also want to make sure that if the connection goes down, we want to clear out this listener. It's kind of interesting, like, do we really want to put that responsibility into this thing? Like, you could argue that the consumer should listen for on close, and when it's closing, you don't get a disposer back. But what you do in a callback is to dispose of everything you were listening to. I'm just trying to understand how. Yeah, how would you do that? Fuck, it's a fucking neighbor again. They're renovating their basement. Like, I love our neighbors, but I hate renovation. Dispose on message. How should we do this? So what would happen here is that when we close, we dispose of this. Which is great. But then we also have to dispose that we dispose when we close. That's the thing that's kind of making this a bit icky. But it's like, if you close, it should clean up everything. So you could argue that when it closes down, there's nothing to dispose anymore. It even disposes the event listener for this on close, right? So I would say our close is basically well, of course, you might listen to on close and then you just don't want to listen to on close anymore. Yeah, no, let's just do it like this. So when we where did we go and fix this stuff? So when we on close, we listen to close and then we return a disposer for that. When we listen to on open, we need to do the same. So dispose on close connection. Once dispose on open. I just wonder, would this be like the pattern for doing this kind of thing? Yeah, it's interesting. So we have this open. Yeah, like this would be incredibly hard to debug. That's the thing. Like it doesn't make things simpler. Because if it was closing, if it closed down, you would still have all these disposers here wrapping over the connection, which aren't cleaned up. Yeah, this is a bit tricky. I'm not sure how to think about this. It's almost like maybe, yeah, so maybe on close, and like maybe that should be dispose. So you have something called on dispose, but it doesn't return anything. You can't dispose on dispose. That doesn't make any sense, because it cleans itself up. That's the whole purpose. So let's explore that. So export function on dispose, connection WebSocket, and then you just have this thing. And then what you do is dispose on close. You listen to close. That's the thing that triggers the disposal. And then it should call the callback, and then it should dispose on close. It should dispose of itself. That's the thing. So it basically means that whenever the connection closes, we want to clean up everything. So when you have an on-close listener, that should be removed when it's disposed. So what's a little bit meta here is that disposing is actually closing the connection. But you can argue that on dispose should, let's see, dispose close. Sorry, dispose on close. Right? So we add the close listener. We create a disposer for this listener. But then, yeah. But then, of course, what you could argue now is that every time we call on close, we'll create a dispose listener that we don't really need, which we should really clear if we manually dispose of this on close listener. Yeah, I think this kind of adds, I don't think this makes sense, that you should internally clear all listeners. That should be the consumer. That's, at least that's going to be my statement in this implementation. So if we clean this up, we don't do this. We just return on message. So basically, when the connection closes down, you are in charge of cleaning up any listeners. like that's a thing. Like yeah, that's interesting here because you won't have these high level listeners either. I think they will actually be more tied to. Yeah, we can explore that. So that was something that created probably a lot of confusion and was completely unnecessary. So what we're going to do is we're not going to do this. We're just making it simple. Cool. Oh. What's this? On open. Sorry, should just be this. Let's not make it harder than it is, or that it needs to be. Okay, so we have on notification. We should really just come straight to request. So as I said, we don't really send anything low level. The only exception is the heartbeat, but that heartbeat is implemented with creation of the connection itself, so we don't have to think about that. So when we make a request, so this is where it starts getting interesting, because we have our WebSocket client, which like currently just sends data, but we are going to look at where's picture client, picture message handler. So this would be, yeah, so we kind of separated the message handler from the actual WebSocket connection. Like this, again, this is like designing by concept instead of behavior. So let's look at how this would be when you send a message. I think we have, yeah, create request. So this is interesting. We are, yeah, this is going to be interesting. So let's not do anything like this. So what did we do when we removed send? Didn't we? Didn't we do stuff there? Didn't we like encode a message and stuff? Anyways. Okay, so when we ask a request, you can see here we have this concept of like a pending message and all that stuff, but we shouldn't need that. The only thing that's a little problematic here is that we have this concept of a message ID produced by the client. But the thing is that this is a global thing. It just needs to be, so this can actually be part of this. So we can just do next message ID. And then we're not going to create this pending picture message. We're trying to implement this more as is, and we don't need to delete the pending message based on disposal, but we do we might want to remove some listeners related to we'll figure that out. Okay, so we're creating this pending picture message. And we have like this whole thing of pending picture message class. It has timeouts and it creates a request payload with some data. Where's the data coming from? It's coming from the request. Okay, so we have pending. So this is okay. So the question is, when we make that request, I guess we want to make it a promise. That's the point. It should return a promise. So let's take this and say that this is async. It has this generic. Why is it complaining about that? Why are you complaining about this? Is it just because I'm not using them? Okay. Yeah. So request would be T. There we go. And this should be a promise of R and are we explicit about method? Yeah. Cool. I think this is correct. So we pass it a request, which is a picture request, a method, and its params. And then we expect to get a picture response back, which is tied to the method of what we're sending. Like that's the type. And then we are producing this message. So I guess this is actually sending the thing. Oh, there's a picture message timeout thing. Okay, this is going to be interesting. So let's remove this. Let's remove this. So we don't do anything about this. Data is perfectly fine. We don't need to set that method. We don't, we just create a payload. Create request payload is not from picture client. God damn it. It should come from the protocol, I believe. Yep. The same for this. Why does it say picture client? So annoying. Oh, I don't think. Request payload. And it returns. Yeah. So this is the. I guess this is a request payload. Okay, let's call it payload. And then we have a timeout ref. And I guess we remove this picture message timeout thing. Where's this? It's here. Where's that thing? Picture message timeout. I thought that was in here. Oh, it's in the message handler. Oh, it's actually part of that thing. Okay. Cool. We have the payload. And then we are saying that if this is reaching the timeout. Yeah. So this is the interesting thing. Previously, like we had this message handler that would just create these pending messages, and then some other part is actually dealing with the actual messages going in and out. So that's why we had this receive message here, receive message, so that it can like decode it and match it with any pending messages. But we're not doing that anymore. We're just sending the request. We are let's see, let's remove this so it's a little bit more clear. Yeah, we don't need, yeah, so the whole point here is that so we have this weird like logic around promises where we kind of extract the resolve and reject and all that stuff. We're not going to do that. We're just going to return a promise here. So we don't even need this to be async in that sense. So we're going to return a new promise, which can resolve and reject. And that's where we're doing the logic. So what we're going to do is we're going to say, again, on message, we'll give it this connection, dispose on message, give it a connection, and when we get some data, this is the coded data already. We check if is response message. Wait. Oh, this is something else. Is result payload. Is result payload. So this will be the payload. And payload dot ID equals our ID. Else if is error payload. And payload dot ID equals ID. That means it's the message we are waiting for. And of course, for some reason, that's not here. And if it's our payload, then we just resolve the freaking thing as T. Is that possible? Sorry, as yeah, this is the fucking annoying thing about of course it can be as unknown. I guess we don't even have to. Yeah. As any, I'm just doing any now. We don't really care about this. Does it actually return? Yeah. Can I do unknown? No. Has to be any. That's so annoying. And then we'll reject it. We reject payload as any. Cool. And now we have to ensure that this is just like, again, like coming into this code, it's so much easier to understand. Oh yeah, we have picture message error. Oh wait, response. Oh yeah, wait a minute. There's statuses here. Is result payload? How do we check that? How do we check that? Is result payload? Why are we checking the status and all that stuff? Crypt request, and we receive this promise. Resolve with a response. I think that's what we're doing inside is picture result. We check if it's a result. Let me check something here. Payload. So is result payload picture response payload. Funny. Yeah, so here we have the status and then we have the result there. Okay, sorry. So what we want to pass here is the actual payload dot result, I think. Yeah. But our picture response, sorry, I can't remember. Yes, we have result. Oh, okay. So what we actually want to do here is that we want to resolve the method status. Doesn't R have a result always? Oh, it doesn't. Oh, sorry, this is picture response. Okay, this is interesting. So method status, yeah, picture response status. This is interesting. Can I get some intelligence on that? Oh yeah, because it's not. Oh, god damn it. Resolve, that's what we're actually resolving. And then what we're resolving is the result. And this is interesting. Okay, so this is the actual promise result. I have no idea why why can't it be used to index? Why can't it be used to index? This is kind of annoying because now what we really want to be, we just want the result. We don't. We just want the result. Why is it saying that this can't be? That's not really true, is it? So we have a picture response with the same method and it's resolved. That's the thing the promise resolves. Okay, you could state that, okay, doesn't matter. We're not actually going to use this. So we're going to do the payload thing as any. But at least we have the correct typing. So you will actually get like a response object where the status is resolved, and you have a result method property to actually grab the data, which is fine. While on error, you will have like rejected, and you will have the error there. I don't know why we have a wrapper around it. Where is it? Pending picture message. I thought I saw something. Yeah, new picture message error. Yeah, I think that's so we can identify. So we would do new. Yeah, and I guess we have to bring this into scope as. Yeah, and this is coming from somewhere else. This is coming from new. Oh, we actually have it here. Yeah. Okay, but we're stating that we actually don't need that. We just give it a payload, and you just have to check that. Like, that's the problem with promises. The error you get on catch is just a completely unknown type, which is drag. Okay, so now we want to actually send the message. And how do we actually do that? So we create the request, and I guess the message handler is creating the request. Create request, and then we send on the picture connection. We do send picture connection. I think that just sends to the procedural. Yeah, so it could, we have something called request. Yeah, so we're just going to use the connection because this is the only thing that actually cares about sending, and there's nothing special. Yeah, I think this is perfectly fine. Payload. So we send it on the payload. Yeah, so this is interesting. What do we do with the timeout? So what the other code did is that it actually, what did it do? The timeout, create request, new pending picture. When do we have that time? Yeah, it disposes the message itself. So I guess it means that on timeout we stop listening for messages. Yeah, the problem though is that currently so we would, this makes sense. So if we have a timeout, we dispose and we reject the promise. Message timeout. Yeah, this is good. Yeah, so this is interesting. Like, this is a typical thing where maybe we should just call it const dispose. So we do a clear timeout on timeout ref. We dispose on message. Yeah. So when we when we resolve, we dispose, and when we reject, we dispose. So this timeout doesn't trigger and calls the reject when it's already been resolved or already been rejected. Cool. And then we send the payload. And there's so much stuff happening here. This unwrapping. Yeah, so the only thing is that when you unwrap here, you actually get the result, but now that's an object in itself, which is perfectly fine. Okay, so we completely remove the pending. And when we receive, we just call the callback. I'm not sure why. Are we mapping this to something else? Error code, error data, payload error message. I don't think we need this. Because this is already coming from the server, which is interesting. Anyways, message to resolve. Yeah, so here is the resolvement, don't need that. And then handle disconnect. So that, I guess that's the final thing. It's like we have timeout, but we might also have a close connection. On dispose on close, which would be on close connection, we run dispose, which would again dispose of on close. So we just have this general disposer that just disposes everything, regardless of it being a timeout, it being actually getting the message, or the connection closing down. Yes. And then we send the thing, and that's it, right? So one thing you can argue is that Now we don't have, now all the messages are tied to the connection, and we're saying that when the connection closes down, it's disposed, which means that all pending messages is also disposed. So I don't think that makes sense. You should be able to reopen the connection when it's closed. Is there like a WebSocket? I don't know. Like reconnect or something? Ready state? Is it just open on? Oh, that I thought you could on open, on close. Okay, this is interesting. I thought you could reconnect a promise connection. Maybe you can't. But that means we just need to create a stateful connection. So that's not like a huge deal, but reconnect WebSocket connection. On open, send one message, blah, blah, blah. Yeah, connect. You actually have to create a new WebSocket item. That's okay, cool. But that answer, I didn't explore that. So basically what we're doing now, we are using a WebSocket connection as the data, kind of, or the low-level stateful thing that these things operate on. But we should have our own connection object. What that well, we don't have time to explore this, but what this basically means is that we would have we would basically have our own connection object that hides the detail that it's a WebSocket connection, and it allows to like create multiple connections. So you have like maybe a reconnect method or something like that. And what that would mean for this request is that if for some reason the connection closes down, we are able to resend it when it's connected again. Yeah, so that would be an interesting iteration. Like, think about that connection as something that can reconnect, and then we could also actually have dispose, which is also interesting. Yeah, and the big question is like, why couldn't then that thing be a class that just holds everything, right? Maybe that's the thing here, is that it's not because it's object oriented, it's just because we don't express this in a more simple way. And then you can argue, was it the object-oriented mindset that made it so complex? So by having this procedural mindset, it just automatically becomes simpler? Or was it because I refactored the thing after we knew exactly what we were building? Because it's kind of hard to defend that we have this stateful object with behavior return as a connection, and then you have these decoupled functions that just basically calls methods. So here we wouldn't have add event listener, we would literally have on close. And why have a separate on close when you can just call it on the connection? You have to pass in the connection anyways. Well, you could argue like, who's responsible for what? So you could say that this low-level connection object isn't. So there might be additional logic to closing. That this low-level thing doesn't care about. I don't know if we have. Yeah, so for example, on message, like that low-level connection doesn't do all of this. It just has a listener for the message. Yeah, it's very interesting. But I'm going to continue this exploration. Let's just work in progress. Let's just commit and push if possible. Maybe I'll get some errors here. Yeah, we have to do. We have to do this manually. No verify. That's how we do it. What the fuck is this? There we go. Yeah. Setup stream, origin, draft, nervous. Let's go. Yeah. So that's what we're going to do next time. We're going to change this connection object to not be the one WebSocket connection, but to be just a type of what these other APIs need. Yep. But it's interesting. Like you could. Yeah. So you could say, okay, you need to create a binary connection. That could be the type, binary connection. Yeah, no, I don't know. It's interesting. Yeah. Yeah, is closed, is connecting. All of this is like, why don't just look at this binary connection? If it's open, if it's connecting, if it's closed, why call these other functions? And I guess that's the tricky part here. It's like how do you, why do we separate that? Yeah, I have to reflect on this. Like, this is only conceptual exploration. It's not like how to implement something. It's like, why implement it this way? What is the concept? Why does it make sense? So you could like extend the responsibility of that picture connection. Like it could have the message ID, the state of the message ID, for example. Stuff like that. Yeah, so you could say that this create a WebSocket connection. Yeah, this is the thing that's like is dynamic. Like all these other functions, they only care about receiving a picture connection. They don't care why that it is a WebSocket connection. They just need a picture connection. But still, like why would you choose to create a separate function as opposed to just having it on the object? Is it only is it like a mental crutch? Maybe it is. Yeah, no. It's very, very interesting. But okay, I have to stop, and then we'll talk more about this later. I find this super interesting, so I'm just going to keep doing this. And we'll jump into something else if this gets boring for everyone else. Okay, bye for now.